Hey, so I got a lot of questions in the email about what exactly is the small notebook class. So I thought I would go ahead and offer an explanation of that right now. Essentially, as I've taught AMC and competition math, especially AMC for the last 15 plus years, as I go through the textbooks and I do various problems and I go through lecture portions, and as I've taught the questions on the test that have been around for the last 25 years, I come across concepts, formulas, shortcuts, techniques, ways of thinking that I then record in my own version of a small notebook. And so an example of that would be like on this first page, you can see, oh, it might not show it. It shows that the area of a trapezoid, these side triangles are equal for any trapezoid. And if you have a quadrilateral in which you get the side triangles equal like that, then that is automatically a trapezoid. So it works both ways. It's ideas like that that I have written in my small notebook throughout the years, and that's what I'm going over in this class. If you watch my solution videos, all the time I'll say this is a small notebook concept, meaning it's really important. It comes up more frequently than other ideas, or it's a very powerful technique. And so you should write it down and record it in your small notebook. If you're in one of my classes or you ever took them, you'll hear me say this phrase all the time. Essentially, the small notebook is a condensed version of everything that you've learned that could ever be used in a problem. Except I don't really go into a lot of more normal concepts. I don't typically talk about, I don't know, parallel lines, corresponding angles, really basic concepts. I don't go into that. These are more things that if you don't know them, you can't solve the problem. And so are they guaranteed to come up? Not guaranteed. Every year, usually three or four of them will appear or more on every test. The only test where it was a little bit lighter was last year's 2024 10A. The B had plenty of these concepts, and so 2023 had a ton of them as well on both contests, both for AMC 10 and AMC 12. And so that's what it is. It's all of my notes for the last 15 years of what I've considered to be the most important. If you don't have a notebook like this, I highly recommend this one. It's made by a company called Moleskine, and you can find it on my website on the resources page. If you scroll down, it's the first object past the AOPS books. And so, what is the class like? It's been going on for 3 years now. I'm going to show you a review that someone left of the class 2 years ago in 2023. And then I'm going to show you, I'll also attach to this video the same thing I put on the previous one, which is a sample of my small notebook class so that you can see exactly what the class is like as we go through. I will go through concepts and then I will show you typically where those concepts have appeared on an AMC question so you can see what it looks like in action. For now, here's the review from 2 years ago. Again, back then it was only a 3 hour class. Then last year it was 4 hours, and this year it's morphing into a 6 to 8 hour multi-session class. It said, "Hi, James. We are overwhelmed in amazement. The best 3 hours spent on a Sunday. So much material, concepts, advanced concepts, and thought process. And all it was awesome. We both sat through the class. Thanks for letting me be a part of it. I let the father sit in. And we are still in the process of combining our notes. Almost 50 pages altogether, plus many screenshots. It will take a couple of days to reconcile. Ordered a set of small notebooks for the name of the student, and he will be using it from here onwards for every new concept. Once you put the recording on YouTube, please share. It'll be very helpful to watch it again while reviewing the notes that we took. Regards." Okay, so that's that. That's a review to give you an idea of what people said 2 years ago. And since then, the number of material, the amount of material I've gone through has actually greatly increased. Let's also go and show you now what the current schedule is. And so these are the classes that are currently available for it. Please note, these are not the same class held on different days. Okay, it's each a different unique class. So the Wednesdays class meets every Wednesday. The Thursdays class meets every Thursday. The Saturdays class every Saturday, and the Sundays class every Sunday. And you might say, how will the Thursday class make up? The class is probably about 7 hours long, And so they will cover 6 hours in the first part, and probably the last day will make it a 2.5 hour course rather than the 1.5 hours on that final day. And so class one is Wednesdays. It starts tomorrow. If you want to register for this class, please reach out right away. It's already got enough students. It will be launched tomorrow. It's going from 4 to 6 p.m. on Wednesdays, Pacific time, starts October 8th. So by the time you see this video, it will probably be today, meaning you'll be watching this probably on Wednesday if you see this. Class two is Thursdays. It starts the next day after tomorrow. Class three is Saturdays, and class four is Sundays. Currently, the only two classes that are guaranteed to happen is Wednesdays and Sundays, although Saturdays and Thursdays does both have one student signed up so far, and there will probably be a couple more added. If you're from an international time zone, say India or China or Korea, there is a class that I'm going to be offering as an option if it gets at least 5 signups. It'll be Beijing time on Sundays from 11 a.m. to 1 p.m. So you will have to modify that to your time zone to see if that's one that you would be able to attend. It's Saturdays, 8 to 10 p.m. Pacific. So if you are in the US and you wanted to attend that one as well as a later at night option, you would be welcome to do so also, as long as the class actually forms. Finally, there's an optional class on Mondays that has no signups yet currently. It may or may not happen. And then lastly, it never fails. In between the A and B tests, some people want to take the class and they've already missed it because they don't find my channel till it's too late. And so this is an optional intensive camp that would run in between the contests on Friday, November 7th, and then Monday the 10th through Wednesday the 12th. The likely time would be around 4 to 6 p.m. Pacific for all of those. Now, if you are my student in my classes, you've taken classes with me or more than a month of private tutoring, you are going to get a discount on the class of $80 off. And so reach out to be able to use that. If you're one of my subscribers in my Saturday live streams, either the monthly or the yearly, you can reach out also and you will receive a different discount equal to 1 month of the live stream that you will get access to this as well. So if you'd like to sign up, I can only encourage you to please sign up quickly. After the class gets started, you'd have to make up the time somehow. And again, the class starts tomorrow. Not sure what else to add except, oh, in just a moment. Sorry, I'm really tired. It's 10:40 at night here. Been a long day already. I am going to have right after this a sample from the class. You also might want to watch 2 other videos. The Small Notebook, Justified and Explained, it'll be in the description. And you're probably going to want to watch the Making of a Small Notebook concept that came out about a month ago, where you can see a live situation where I'm teaching a class and we discover what I considered a small notebook concept, and then I added it to my small notebook. And that's exactly how all of these concepts were born, is things that you observe that could be very powerful in a problem-solving situation, especially under the pressure of time. So it's not guaranteed to qualify you for Amy. I'm not promising that. I will promise it will give you an edge. It will give you an advantage, provided that at least 1 or 2 of the concepts appear, and inevitably in every year they do. It's just that some years you get 8 concepts and some years you get 2 or 3. And so, yeah, that's what the class is all about. You can sign up through my website, reach out to me, and we will get it going from there through email after that point. Hope you enjoyed the video. I hope that answers all the questions about what the small notebook class is. I will also consider doing a single day class, but it would probably have to be a condensed version and you wouldn't get as much as what these classes are getting. That would happen maybe on a 4-hour session on Saturdays or Sundays, the weekend before the contest. So other than that, thank you for watching, and I will see you in the next video. In fact, we're going to use it again here in just a moment. I've not seen this in an AMC. Not every concept in here was an AMC because, again, there's going to be 7 to 8 novel problems every year that no one's ever seen before. So what are they going to put in those? No one knows. Try to know a lot of things that are interesting. That seemed interesting to me. I copied it down. The next one's more important. For orthodiagonals, this is going to have 2 parts. Orthodiagonals. Okay, the first part is for any orthodiagonal. All that means is the diagonals are perpendicular. Okay, so it doesn't, common ones are a rhombus and a kite, but it does not have to be a rhombus or a kite to be an orthodiagonal. Those are just examples of things that fall into this category. Okay, any orthodiagonal, and you can make one that's neither of those by making sure none of your lengths are the same length. They all can look different. I draw the diagonals first for that kind. That way it won't look like a rhombus or a kite. Okay, D, A, B, and C. You should know that the sums of the squares of opposite sides are equal. So A squared opposite from C, A squared plus C squared equals B squared plus D squared. That would be more about a speed edge. More importantly is the area. It's equal to half diagonal 1 times diagonal 2. The reason for this is obvious. If you come out here and make a rectangle, then this is half of that. And this is half of that. And this is half of that. And so, of course, the rectangle's dimensions are diagonal 1 by diagonal 2. Okay? I'm going to add a concept that's not in my small notebook so that I can show you this concept in action. Because again, one concept is not enough on more challenging questions. You're going to have to combine it with other things. This one's not in mine. I don't have everything I know in my mind in my small notebook because some things to me, I just can't forget, but you should probably add it to yours. So it doesn't have a number, okay? It's got two parts. The first is called triangle midsegment theorem. Triangle midsegment theorem says the following. If, put A, B, and C, if you have midpoints, M and N, okay, those are midpoints. So I don't call them midpoints in mine. Why? Because the symbols indicate they're midpoints. If your brain can't process those are midpoints by the symbols, you're going to have more problems. So you want to have as minimal writing in your small notebook as possible. Then the following two things are true. One, MN is automatically parallel to BC. And two, MN's length is half the length of BC. That's the first concept. Related to that, not same theorem, is if you have a midpoint on one side, and all you know is that the line here is parallel to this line. It's all you know. You don't know N is a midpoint. You only know M is a midpoint. Then by that, you now know N is a midpoint. This often comes up as a concept in trapezoids when you draw the diagonals. So if I put a midpoint here and I start going this way, and I know that this is parallel to up here, you now have that concept applicable because it's guaranteed to pass through the midpoint right here, N, as well, because it's parallel and starts at a midpoint. So you'll see it a lot of times. They'll hide it within trapezoids when you draw the diagonals. It's a common application of it. Often it will have this little segment in the middle of the two diagonals. It's actually connecting the midpoints of the diagonals as well. But the way you would solve a problem like that typically involves the bases, you know, where you double this base or you cut that base in half to get this one, and then you cut this base in half to get like that length, et cetera, et cetera. There's lots of options with that situation to be played around with in there. Okay, I'm going to clear screen. You have about 5 seconds to get a screenshot. Be ready to take screenshots when you're too slow in writing. You're going to write a lot. Okay, I'm going to clear in 3, 2, 1. This is also not in my small notebook. It's just a similarity understanding. I'm going to need it also in the problem we're about to do. So similarity, all lengths are in a ratio. All of your areas are a squared to b squared. All of your volumes are a cubed to b cubed. You might note that certain shapes are always similar. Sphere, circle, cube, square. All such shapes are similar to each other. You don't need to have any proof that they're similar. They just are. Okay, just trust it. You can look it up later, some reason why. I mean, it should be kind of obvious for anybody who understands similarity, but yeah. Okay, So similarity. Now I'm going to clear that off. You probably all knew that. Again, that's in my AMC 8 small notebook. I don't have it in the AMC 10 because I just consider it too basic. All right, so this is a 2020 AMC 10A, and we're going to look at problem 12. What I'm going to show is kind of how you would take this concept and how it can quickly resolve the problem. Is this the only way to solve this problem? No. And you might have found a different way when you did this test as a mock. Okay, but remember this also. They're going to hide what they want you to use or critical information behind other words like medians. What does medians mean? Oh, it's from a vertex to a what? A midpoint. Guaranteed. V is a midpoint. U is a midpoint. Connect them. What do you have? A triangle midsegment. What do you know? Its ratio is 1 to 2. You also have triangle similarity. Okay, so you have triangle similarity. And what that would mean is that because you have a 1 to 2 ratio, the area here is A and here 3A. Because A to A plus 3A is a 1 to 4 ratio because your segments are in 1 to 2. Note that from the start of the problem, the UV is not connected. Why? Well, number one, you might think to use it. They don't want you to just know what to do automatically because they told you. They want you to connect ideas in your mind to things that you should know. So they play hide the ball. Can you find it? Do you know how to act upon it? There are median properties as well that you can use. The fact that this is a centroid, you get 2 to 1 ratios. All of those things are valid. Okay, but that's not the method I'm going to use here. Once you connect this, this now becomes an orthodiagonal, and they're perpendicular on the diagonals. So your area of it is half times 12 times 12, which is 72, which means your 3A is 72 and your A is 24. So immediately, what is the area? 96. Okay, it's about getting speed edges. If I'm doing this problem, this is exactly how I did it the first time. The first thing I do is go, okay, the fact that AM was equal to AC, we never use that, by the way. You could have, there's probably some solution that does. I saw medians, I say midpoint. I thought about connecting immediately because this is a common trope in competition problem solving, where you have the midpoints connected like that. Okay, so I connect immediately. I go, oh, orthodiagonal, 144 over 2, 72. Oh, that's this, 24. A is 24, 96, you're done. You can get the whole problem if you're trained and you understand these concepts in less than a minute. Okay, it's a number 12 on a modern AMC 10.